Happy Friday! This is a similar lesson to the last one because we're going to talk about similar triangles. Okay, but first, we must warm up. We don't want to strain any math muscles. Write a similarity statement and identify the scale factor of the larger triangle to the smaller triangle. All right, let me color coordinate these. So I'll call this one my blue. Blue's the bigger one. Red. They're showing us which angles are all congruent to each other in each triangle with the markings. So when I'm writing my similarity statement, super similar to when I'm writing a congruency statement, doesn't matter what order I do it in, I just have to be consistent with the second triangle. So if I start with my big one, A, B to C would probably be the easiest way to do that. Single to double to triple arc is similar to that symbol, looks like that. Triangle. All right, so now since I started with A, I got to start with the corresponding congruent angle, P, M, N. Would definitely be the easiest way to do that. Okay, so there's my similarity statement. Next, it says identify the scale factor of the larger triangle to the smaller triangle. So I gotta go from large to the smaller one. So you can pick any of the sides. You don't have to check all three. They're telling you that these are similar. Okay, so I just did like the longest one. So 30 to the longest side of my red one, 20. And with scale factors, we want to reduce. So this scale factor is 3/2. You could not have 2/3 in this case. We talked about it when you can have different scale factors, but because I specifically said from the large to the small, 3/2. Okay, any questions on that one? Obviously, you don't have to pick that side. You could have done, I don't know, 18 to 12. Now I'm given a couple quadrilaterals. What kind of quadrilaterals are these? Trapezoids. Specifically, right trapezoids. Nice. Right trapezoids. All right, so they're telling us that these figures are similar. Right here. Find each missing value. So you got to find X, CD, RS, and then some missing angle measures. Oh, boy. Well, before I can find CD and RS, I got to first find X. All right, this time, my larger one, I'll still use blue. My smaller one, I'll use red. So the corresponding side pair that they're giving me are these ones that are formed by the two right angles, right? This height of the trapezoid. In my blue, 42 corresponds to 25.2. Now you don't even have to reduce that scale factor to solve for X. You can if you want to, but you don't have to. We know that if these are similar, that all the corresponding side length ratios are proportional to one another. Okay, so now I'm going to set up the one I'm trying to find. So in my larger, since I started with large on top, I have to be consistent. 3x plus 10 corresponds to the longest side in this trapezoid, the x plus 18. And now you have a proportion that you can cross multiply to solve. Okay, go ahead and do that quickly. Okay, you guys getting pretty solid at solving proportions yet? No? Do we need more practice? Kind of some weird large decimal numbers, no worries. We got this. I got x to be 15. X to be 15. All right, so then to find CD, pretty easy math to do here. CD is x, 15 plus 18, so 33. Couple ways you can find our S. You could set up another proportion if you wanted to. I want to do that. Now that you know what X is, I would just plug that in. 3 times 15 plus 10, that gives us 55 for RS. This next one's interesting. I don't think we found any angle measures. Any guesses to what the measure of angle P would be? This one right here. Ooh, Tyson, you're the first hand I saw.
117.
Okay, how'd you know that? You're right. I just knew. Okay, Alex?
It's just like up there, like A, B, C, D is about
Okay. Good. In similar polygons, the corresponding angles are all congruent. I love how you explain that. A and P are in the same spot, so those two angles would be congruent. Good. All right, angle D. Ideas. Matthew?
360 minus 180 minus 160.
360. All quadrilaterals, the interior angles add up to 360. Minus 180 from these ones. Minus 117. What'd you get as an answer? Matthew?
I didn't do it.
Oh, you didn't do it?
No.
Oh, okay. What'd you get? 63. That's what I got too. 63. Okay. Now, if you understand similar polygons, similar triangles are similar. They're actually a little bit easier. There are some characteristics that we can show within triangles to prove that they're similar. Okay, so these theorems might sound familiar, and they should, because we did our triangle unit not too long ago, and we often prove triangles congruent. There is a difference here. We're not proving triangles congruent. We're proving triangles similar. Okay? So look at this first theorem. Side, side, side. That looks familiar. This theorem says that the corresponding side lanes of two triangles are proportional, then the triangles are similar. So I'm not checking for congruent sides, I'm checking for proportional sides. All right? So there's a difference between side to side and this theorem. So this one I often abbreviate. You can still do it side, 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 but you got to do side, 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 sim. Obviously short for similarity. Okay? Now, in order to use this theorem, you have to show that all three sides have the same scale factor or are proportional. Okay, so in this drawing, and if you want to get out some highlighters or colors, whatever you want to do. But I got to show those corresponding sides. So JK to QP. I have to show that these are all proportional. So all of these ratios are equal to one another. Okay, the green ones, LJ to QM. Make sure you're keeping the triangles consistent with what you're putting on top of these ratios. JK to MP. As long as those are all the same scale factor, then we know the triangles are similar. So if this, should have put if here, then triangle LJK is similar to, not congruent, is similar to LJK QMP. Okay, now we did that technically in 7.2. If we wanted to check if any polygon was similar, we had to check the ratio or the scale factor of all the sides. So it's really not new, but there's a theorem for it with triangles. Okay, here's a fun one. SAS is back. Side angle side. Side angle side sim. If you can show that two corresponding sides are proportional and the included angle, just like in the statement, the included angle of the two proportional sides is congruent, you can say both the triangles are similar. All right, so in this little setup here, if I look at these red segments, if RS, which corresponds to XY, if that is proportional to ST, which corresponds to YZ, and their included angle of those two proportional sides are congruent, that's enough to say or to prove the true triangles are similar. I'm trying to say the two triangles are similar. Then triangle, let's go RST, is similar to triangle XYZ. Side angle side. Kind of a little bit of like, I don't want to say hinge theorem because the two sides aren't like congruent lengths necessarily, but logically, like you can kind of think if those are forming like the same exact angle and these two sides are proportional to each other, then that third side is going to be proportional to the other third side as well if it's forming that same angle. Okay. All right, last one. This one's cool. Angle sim. Angle sim. This theorem says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Why do we only need to show two angles are congruent?
Because the third one would be the same.
Yeah, the third one would have to be the same. So we don't even have to check all three, because if we can at least just show two, the third one's also going to be congruent. And if all the angles are congruent, then the triangles are going to be similar. Okay? So in this case, if angle A is congruent to angle F, and angle B is congruent to angle G, that's enough to prove that two triangles, why am I struggling to say two triangles? Two triangles are similar. A, B, C, so I gotta go F, G, H. Order matters. Okay, that's basically the new stuff for today. Now we're just gonna do 6 problems, 6 example problems. So these first 4, the directions are all the same. Determine if these triangles are similar. If they are, write the similarity statement and explain your reasoning. All right, so I look at these two triangles here, and I'm not given any side lengths, right? I'm not given any side lengths. So the only possible way I could prove these two are similar is by angle similarity. Can't obviously use side, 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 or side, angle, side. I don't know any of the side lengths. So let's check. Again, I'm going to use 2 different colors here. Here's my blue triangle and my red triangle. Right away I see, hey, 57 and 57, a pair of congruent angles. But then in the red triangle I have 48, and in the blue triangle I have 75. So do we just give up and say, oh, no, they're not similar? No, we don't. How do I find this angle? Alex, go ahead. Oh, sorry. Yeah, go ahead, Alex. Exactly. We got a total 180 here. Somebody give me that number. Somebody got some engaged in following along. 75. Thank you, Walker. 75. We could have also done the same thing, obviously, in the blue triangle. But then we're like, all right. We have 2 congruent angles. That's enough. We know angle M is congruent to angle L. And now we know angle K is congruent to angle P. That's enough to justify these triangles are going to be similar. So let's write our similarity statement. I'll go JKL is similar to, all right, so I'm from 48, 75, 57. So I got to do Q, P, M, explain your reasoning, by angle sim. It's that easy for that one. Let's look at another example. Same directions. This time, I'm not given anything in these triangles. No side measures, no angle measures. The only thing I'm given are these. What do those mean? Parallel. parallel. So again, if you're not given any side lengths, the only possible way to prove these are similar, angle, angle. Anybody see any congruent angles? Ooh, Libby, idea.
They're, I forgot the word, but they're, it's a V, isn't it? Something like
Oh, okay. Are you talking about these angles?
that. Yeah.
These are going to be congruent. Tyson, can you help her out?
Oh, vertical.
What'd you say? Vertical angles. You knew it started with V. Vertical angles. Good. There's a pair of congruent angles. Okay, let me just jot this down. I'll come back to you, Tyson. So Q, we can't call that angle X and angle X because it has two angles coming off. QXP is congruent to angle NXM by vertical angles. Okay, Tyson, you had another pair?
Q and N are alternate exterior or interior.
Good. So if I were to extend these parallel lines, you might be able to see this better. If I were to extend these parallel lines and think of this as like a transversal, you see the pair of alternate on opposite sides of the transversal, interior inside the parallel lines, alternate interior angles. Good. Angle Q is congruent to angle N. You could have also said M and P by alternate interior angles. Two angles are congruent. Therefore, the third angle is also being congruent. Therefore, the triangles are similar. So, write our similarity statement. Triangle QXP is similar to NXM by angle sim. Okay, not bad. All right, so got a couple more where it's not as easy as angle. Let's throw in some sets. Some set aside. So here I'm not given any angle measures, but I'm given a lot of side length measures. Now I still have vertical angles, but I don't have any parallel sides, so I can't do anything besides knowing that the vertical angles are congruent. But I'm given the three sides, so this kind of shouts out, let's see if it's side, side, side. We can show that all the sides have the same ratio, same scale factor. We can say they're similar by side, 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 sim. Now, sometimes people get confused on which sides correspond to which sides in the two triangles. So an easy way to do this, in your bigger triangle, start with the biggest side, which is 9. And that would have to correspond to the largest or the longest side in your other triangle, 6. Now, it doesn't matter which one you put on top. For some reason, I don't know why, but for some reason I always like to put the larger one on top. I don't know. I just like improper fractions. I don't know why. I notice like I do that every time, no matter like how the triangles are oriented. I don't know. All right, this reduces 3/2. So I'm like, okay, there's my scale factor. That's not enough to prove they're similar. My next longest side I see is 7.5. And then my next longest side in the red triangle is 5. Okay, I remember asking you guys if you knew how to type decimals and fractions, and nobody said anything, but then I had about 10 people ask me yesterday, so I'm going to show you. Your calculator will tell you like error if you try to do a decimal with the fraction button. So you can just do 7.5 instead of doing it as a fraction, do it as a division. 7.5 divided by 5. Now your calculator is going to give you a decimal. We know how to do this. F to D, which is second PRB. And then you're like, oh, a mixed number. This one's pretty easy to convert, but guess what? Your calculator can do that for you. Second, the button right below, the F to D one, that one right there, where it says mixed number to improper fraction, that's how you do it. 3/2. Okay, right now we're on a roll. I have 2 of the same scale factors. I do have to check the third in order to use side to side. So my shortest side in my large and my blue triangle is 6, and the shortest side in my small red triangle is 4, and that also reduces to 3/2. Oh shoot. Okay, so because the 3 side lengths are all proportional, triangle A, B, C is similar to D, E, C. by side, 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 sim. Okay, not bad. Ooh, I love these ones where there's like a triangle within a triangle. So fun. Same directions. Are these triangles similar? So you're like, what triangles are they talking about? Well, here's my large one. And here's my small one. All right. I'm not given any angle measures. I'm given some side lengths. So let's look here. Obviously, they share this like left-hand side. So in my blue triangle, how long is that side? 25, right? 15 plus 10. Good. So 25 corresponds to which side in the red triangle? You can shout it out. 10. 10. Good. Thank you. Reduce that. 5/2. Okay, let's check the scale factor on that other side, on this one right here. Same thinking. This one's going to be 12 plus 18. This one's 30, which corresponds to 12, which also reduces to 5/2. So I have side right now. So obviously, my two possibilities would be side to side or side angle side. I'm given nothing about the third side. No measures, no markings, or anything. Idea. Libby, what do you think?
They share the same top angle.
Woo! They share angle M. Angle M is obviously going to be congruent to itself. Libby, do you remember what property that is?
Reflexive.
Nice. Hashtag impressed. Do you guys still say hashtag? Did I ask you that? Do you say that tag? Hashtag?
Yeah.
You do? Okay, good. Okay, so this is actually a side, angle side, right? Because it's this side to this side, the included angle, and this side to this side. So that's enough to say the big triangle, NPM, is similar to the little triangle. Oops, I used the wrong colors. Doesn't matter what we're doing. Okay, big triangle, RMS, is similar to little triangle, NMP, by SAS, SIM. I'm telling you right now, I'll take points off if you don't put SIM, because side angle side is a congruency theorem. Okay, a couple more. Given RS is parallel to UT, which is marked on our figure with the arrows. RS is 4, RQ is x plus 3, QT, 2x plus 10, and UT is 10. All that's marked for us. Verify the two triangles are similar. Then find RQ and QT. Okay, so I'm looking here, and these parallel lines are usually a dead giveaway that I'm going to have some congruent angles. So just like the last ones, I have a couple pair of alternate interior angles. So you could do T and R, you could do U and S. You could do both of them and call it good. You can show both, or you could do, your vertical angles, whatever you want to do. Or you could do these ones. We'll mark them like that. I did one alternate interior, and then I did the vertical ones. But obviously, it doesn't matter because all three of them end up being congruent. Okay, so right now I'm just doing this. I'm verifying first that the two triangles are similar. So now I can say triangle UQT is similar to triangle SQR by angle sim. And then I can do the algebra here. Now that I know they're similar triangles, I know that all those side lengths, which that's where my variables are located, I know all those side lengths are proportional. Okay? So I'm given a set of corresponding sides that are across from the vertical angles. So in my blue triangle, I'm given 10. And in my red triangle, I'm given 4. Those are corresponding sides. So I know 10 corresponds to 4. It technically doesn't matter which one you put on top, obviously. And I know this is proportional to all the other side lengths. Now, you can reduce this if you want. You don't have to set up your proportion. I personally like to reduce them. It just makes your simplifying a little bit easier. So my scale factor here is 5/2, which means this 2x plus 10, which is across from my double arced angle, corresponds to the side across from the double arced angle in the red triangle, which is x plus 3. All right, so since they're similar, those side lengths are going to be proportional. So for proportion, cross multiply. So it's not too bad to solve. We get x to be 5. However, we're not done. The directions say to find RQ and QT, not just x. So I'll start with RQ, which is just x plus 3. Now I know x is 5. So RQ would be 8 units. Ooh, my favorite line segment, QT. 2x plus 10. So that's 20. Now, because we're always paying attention to details and checking our answers, you should check if your answers of your corresponding side lengths are indeed proportional to that scale factor. So you can check here, 20 to 8. Yep, that would be consistent with my ratio of my other side lengths. All right, you guys, we're one geometry problem away from the weekend. Let's get after it. This one's a great real life problem, so don't say you'll never use geometry in real life because you guys all have shadows when you go outside, right? If the sun's out. Josh wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet at the same time. What is the height of the Sears Tower? You could honestly set up a proportion and easily solve this, but I kind of just want to draw a picture to show you like the similar triangles, okay? And sometimes it really does help to get a visual. Anytime I'm solving a geometry word problem, my first step, if I'm like a little like, what are they asking? I just draw a picture. So let's just quick do this. We got the Sears Tower. Yeah, it's big. And then obviously this 12-foot light pole is going to be smaller. Light pole, 12 feet. There's my light pole. Okay. So I'm measuring their shadows. So let's picture the sun's right here. Sun casts down. And think about where their shadows are. So the Sears Tower, the shadow's on the ground, right? Let's say this Sears Tower shadow length, what did they say, 242? 242 feet. And obviously your shadow is perpendicular if this building is built with a good structure. All right. And then we know our light pole casts a shadow. And if you overlap the triangles like this, it makes it really easy to solve, of 2 feet. Okay, so I have a couple similar triangles here. This is what I kind of want to show you. How do I know these are similar? Well, they both have right angles. What other angle is congruent in these? Good, this one right here, right? That's why we're going to share them so we can form some similar triangles here. All right, so what we really try to find is this height. I'm going to call it X. Call it H if you want, doesn't matter. So let's set up a proportion here. I know the shadow length to shadow length. I'm gonna do the big one again. 242 to 2 feet. Sorry, shadow length to 2 feet. I know that has to be proportional to the heights of the Sears Tower to the lamppost. Write this down. You can reduce this if you want to. Like I said, I kind of like to reduce my scale factors. A, it's good practice to reduce them, and then B, it's going to make your proportion life easier to solve. Okay, so then in my blue triangle here, this side I'm trying to find X corresponds to the height of the light pole, 12. So height of the tower to the height of the light pole. So I know that's going to be proportional to 121 over 1. And I like to keep it as a fraction because then it's just nice and easy to multiply, cross multiply. 1,452 feet. Again, probably could set up a proportion without drawing that big picture, but it's a good visual. And that's it for 7.3. Holla!
Now,
All right, I'm gonna give you 2 things.
you have two options. Either calculate the height of the